Okay, so last time we just went over this stuff. If I have a variable, my var, it's an integer. I've got an int star. What does that mean? Int star. Bingo. It's not an integer. It's a different thing. It's a pointer to an integer. Or an integer pointer, whatever. And what are we putting in there? Well, my var, but I put that ampersand in front. What does that mean? Awesome. Ampersand gives you the address when you put it in front of the variable that you want to know the address of. Like, it doesn't really make sense at this stage. Like, we would put the ampersand by, like, the type, although we will later. Because, like, we want to know the address of something that already exists. So it has to be already existing. But on the left-hand side, like int star there, I've got int star. That means create this thing of this type. That's when it's being, like, created. And then I've got int bar equals my var. And then, of course, I have int baz. So baz is going to be a variable. It's going to be an integer. But foo is an address. It's a memory address. It's a pointer to an integer. How on earth could we put foo into baz? Why was I allowed to do that here? What did I do? Exactly. I dereferenced it. I put the star in front of the variable. Similarly, how do I put the ampersand in front of the variable? But when the ampersand was in front of the variable, that says, don't tell me what's in the variable, tell me where that variable is. When I put a star in front of it, that means, don't tell me what's in the variable, tell me what's at the memory address inside the variable. I could put an ampersand in front of foo. What would that tell me? If I put an ampersand in front of foo, what would that give me? An address of what? It would be the address of a pointer to, right? It would give us the memory address of foo. And what's in foo? Well, it's a pointer to an integer. If I wanted to assign that to a variable, what would its type need to be? This is a really big test, so don't feel bad about knowing. I just want to know if I can push you right now. What would I have to put on the type? No, not a string, not an ampersand. Nope. A double? No. You're, in a weird way, you are kind of a little bit right, but you're absolutely wrong. But more on that in a second. Nobody knows? Let's take one more guess. Who's got a guess? What do you think?
Did you say there was a pointer type?
Well, the star is a modification, right? So star means pointer to whatever this type is. Let's have one more guess. Pardon? Boolean? No. It would have to be int star star. Right? Because it's an integer pointer pointer. Right? Let's make sure I'm right. If I want to say int, let's make sure I'm right. Oop. Foo. Yeah, I think it checks out. And then I'll say, okay, what is boo? And then here I'm going to print out what's at boo. And then I'm also going to print out what's at the thing that's at the thing at there. Yeah, boo. There's no trick here. Let's make sure I'm right. Let's make sure I'm not crazy and I'm misremembering everything. Of course, it's being a little slow. But assuming it's right, oh, here we go. Yeah, there we go. Perfect. I got to make the font bigger, but I'll figure that out for next time. There's no trick here. There's no trick. I suppose I'm lying. There's always one trick. It's what are the rules? Follow the rules, don't look for shortcuts, don't think there's any magic going on here. There's no trick. What is the type of foo? An integer pointer, exactly. It's an integer pointer. So foo is just an integer pointer. And then I asked, what ampersand foo? What does ampersand mean? Address of. So there is a place in RAM somewhere that contains the memory address of wherever foo is, right? And then when I said give me the ampersand of that, that says, well, what memory address is that memory address? Let me draw it. I have my var, and it contains, that's a square, 25. And then I have foo. Right? And what is foo? I'm just going to cut out actually writing the address. I'm going to write the address by just drawing an arrow to where it goes. So the arrow, think of it as the actual memory address. So if this was address 17, this holds 17. In fact, you know what? I'll just write 17 just because. But this happens to be at address 41. I don't know why. So foo is the variable. Its contents are 17, which of course is it's a pointer. And its memory address is 41. So when I ask ampersand foo, what is it going to give me? Is it going to give me 17? 41. Why? Well, ampersand says, give me the address of this variable. And I'm going to put that in another variable called boo. And boo is going to be over here, because why not? Inside of that is going to be 41, which of course really is just a pointer to this memory address. So, what's its type? Well, this is an integer. This is a pointer to an integer, so int star. But then I want a pointer to an integer. So it's going to be int star star. But then, what does the star mean if I put it in front of the variable that already exists? It means give me the thing at that memory address, assuming you're a pointer. So, if I say boo star, it gives me 41. If I say boo star 25. Who here is like, I don't like this? A couple people. Who here thinks like, whoa, cool? I'd like to say about 50-50, but I think more people didn't like it. I got bad news. Get used to it. A lot of times we're not going to get that weird with it like I did here. Sometimes we will, don't get me wrong, we will, we can, and it's cool. But a lot of time, like I'm just showing you stuff. Yes?
Could you like point infinitely, like infinite
Well, it would depend. I guess you could have a pointer. Well, at the end of it, you'd have to have okay, yes you can, but not in this way, not in the way you're thinking. We're going to do that later. Yeah. And there's a good reason why. You'll see. Anything else? Cool. So yeah, last time, whatever. Great. So these operators are complementary. Long story short, I can do this. What would the result of this be? 25. Why? Well, it says, okay, my var holds on to 25, but the ampersand in front of that means, no, don't give me the 25, give me where it is. And then, so now I've got the pointer, the memory address of where something is. But I've got a star in front of that, which means, don't tell me the memory address, actually go to what's inside that memory address. So it immediately just like undid itself. Why would you ever do this? If you wanted to show people that you could. Great. In practice, this is silly. So, let's test you. What gets printed out? Everybody yell it. Good. So far, so good. What gets printed out? Who said address? So foo is the address, but star in front of it means, no, don't give me the address, give me what's in it. Star means dereference, so if I ever have an address, it means go to whatever's at that address. So let's ask again. What will it print out? 25. Okay. Address, I don't know where it is, but maybe it's at 1776 again. Great. What's this going to print out? What would this print out? True. It's true. Why? Well, they're both the address. What about this? Take a second, don't yell it out, think about it for a second.
True.
You're looking at me like, what's wrong with you? Why are you doing this? Okay, let's break it down. Remember, there's no trick except the one trick, which is one of the rules. So let's do the right-hand side first because it's easier. Foo is the address, but what does star foo give us? 25. Okay, great. My var alone gives me 25. But what happens if I put an ampersand in front of it? Then I put a star in front of it. Then I put an ampersand. Then I put a star. 25. So therefore, this would be true. Does 25 equal 25? And if you're thinking, but why? Because. Yes?
Does it just print out true?
Yeah, so it would. I suppose it probably depends on your compiler and whatnot. But if you're using Visual Studio, yes, it would. What about this one? True. False. Any other options? So if you didn't notice, there's actually kind of a trick now, right? When it's this situation, if you just... Yeah. What's the last thing? Yeah. Great. So, here's another test. Who's paying attention? My var is 20. Here, look at this code. Well, okay, don't spoil it for everybody. Ignore him. Don't pretend you didn't hear him. What is my var going to be? Of course the answer is, what? 35. Wait, hold on. Raise your hand if you think it's 35. Really high, I want to see. Raise your hand if you think it's 25. And so, it looks like 2/3 of the class just has no idea. All right. So what's going on here? I am saying, okay, my var is 25. So far, so good. Foo is a pointer to my var. But if I put star foo on the left-hand side, this is going to work. This is going to say, go to that, what's in that memory location. And assign inside that memory location 35. So this will actually turn the result of my var. This will print out 35. This is value, yeah, okay, what's printed out? Great. Now here's another test. Take your time with this one. No skipping steps. I'll give you a minute. Take your time. It's 20 and 10. Oh, do I not print it? Well, let's work through this one. We'll do it together on the board. Oh no, where did I put my marker? No. This one? So I'm just going to write FV and SV. So FV and SV, and they start with 5 and 15. Then I also have P1, which gets me there, and P2, that gets me there. So far, so good. All I've done is the 1, 2, now I'm at star P1 equals 10. So this is what we got to do. So P1, okay, here's P1. But we've got the star in front of it. What does that mean? Go here, and then what do? Make it 10. Okay. Then what does it say? Star P2 equals star P1. Okay, so star P2, so here's P2, here's star P2, there's P1, what's star P1? So what does this become? Now I say P1 equals P2. What does this mean? It always means, the equal means take whatever's in that variable, whatever it's saying, and copy it over. Inside, like what's in that memory location. So P1 is now going to be equal to P2. But what's in P2? This memory address. So P1 is now, it's not going to point here anymore, is it? We're going to take rid of this, get rid of this, and go there. So now I say P1 star becomes 20. So P1 star, what do I make it? There we go. There's no trick. Remember, just the one trick. What are the rules? Take your time, draw it out. Always just take your time. One thing that's really important, and you'll see I even have it to labs, is scrap sheet of paper and a pencil in front of you. Because so many times scratching down the ideas, something like this, is going to be critical to understanding stuff. Every programmer does that. I had someone last year in 162, they came up to me after a lab. This was before I said grab your sheet of paper and a pencil. They came up to me and said, you know, I feel really bad. I always have to like scratch down all my stuff on pencil and paper, but no one else seems to be doing that. And I said to him, well, yeah, you're one of the few people getting everything done in the labs. And what you're doing, that doesn't mean you're bad, that means you're good. No one is capable of keeping track of all this stuff, especially when it gets more complex than this. You just can't do it in your head. So take your time. What are the rules? Don't skip any steps or assume anything about any line of code. Just follow the rules. What are the rules? Simply. That's it. It's a good trick for debugging, too. What are the rules? What are the lines of code actually saying? Don't make any assumptions. Any questions about this weird example? If you had a hard time with this, slow it down. You're trying too fast. You're trying to work too fast. Take your time, draw it out. Yes?
So when you say P1 equals to P2, will the address of P2 be assigned to P1 or P1 to the address?
So P1, so it's whatever's on the right-hand side is going into whatever's on the left-hand side. So the left-hand side was P1, so this is becoming whatever was in P2, which is a pointer to this thing. So if this is memory address, I don't know, X, that means there's an X in here. I just copied over the X, where X is just some memory address. Yes?
So if instead of saying P1 equals P2, you said P1 equals second value, would that now be equal to whatever the second value is?
If P1 equals second value, that wouldn't work, because what is the type of P1? And we have to be more careful. We can't just say pointer, we have to say integer pointer. So the type of P1 is integer pointer, but what's the type of second value? Integer. It would work if we said P1 equals ampersand P2, because that would be the memory address of P2. But that would be simpler, and this example was designed to be like, wait, what? Because this is weird, totally makes sense, it checks out, everything's okay, but it is specifically designed to confuse you. Not confuse you, to challenge you. Other questions? I like the questions, they're good questions. All right. Pointers versus dereferencing. So of course, we've seen star used twice here, but remember, the star when it's next to the type when we're declaring the variable is like a modification on the type. It's saying it's not an integer, it's an integer pointer. If I had an int star star, what would that mean? Integer pointer pointer. What if it was int star star star? Integer pointer pointer pointer. We have to make sure we're saying integer because we can have different types of pointers too. We can have like character pointers, Boolean pointers, and whatnot. And then the star next to the variable after it's declared, that means don't give me what's inside of it, give me what's there. But of course, that would only work if foo is a pointer to something. If foo is just an integer and I said star like my var, would that work? Would that even make sense? No, because it's you can't go there. Yes?
Just on the last slide with that, there was a star and then a space and then a P2. There's already a star on the P. What's that sentence?
So that does mean int star again. Just, it's the shorthand. I actually typically don't like declaring variables. It's because the star's a modification on the, like in the declaration. I typically never declare multiple variables in one line because this gets confusing. If it was me writing it and like I was running out of space on the slide, I would have written like int first value equals 5, int second value equals 15, and so on.
Okay, yeah, I was just confused with that.
Yeah, don't worry, it is, and that's why I don't like doing it that way, because it confuses me too. Yes?
I just run after the one that says P2 is given the value with ampersand second value, get like a little bit lost what's going on.
Sorry, I can't hear you, sorry.
Like if you count from the very first line, from the fifth line onwards, I find it just a little bit confusing.
Here?
Yeah.
Okay. So, okay, there was one other question. I'll come to yours maybe in a second because yours is a longer one to answer. There was another hand I thought I saw.
Same one.
Oh, it was, okay, perfect. Perfect. Did you have a quick and easy one?
So, exactly, so what will be the value in first value? That means its first value.
Well, what is it right now? It's 10.
So that will
We're all going to go through this whole example again slower. But when your questions come up, that's when you raise your hand. Don't wait for me to finish. Just ask when you're like, wait, no, I don't like this. So we're going to start over. It was 5 and 15. Is everyone happy with the fact that I'm just drawing the arrows? Or like, anyone confused by that? No, everyone's okay. Because the only reason I'm drawing the arrow is just so I don't have, like, if this is memory address 400, this would hold on to 400, but I'm just drawing the arrow to mean like, it just gets you there. It's the pointer. Okay, so this is where we are at. So we're now on line 5. So, the left-hand side is what's being updated, right? So it says P1. What's P1? It's this thing. But of course, it's not actually P1. What is it? It's star P1. I'm on line 5. The P1, the star P1 equals 10. Yeah. That's probably important. So I'm at this P1, but I put a star in front of it. Where does that tell me to go? It means follow the arrow. So it actually gets me here. So star P1 is actually this box. It's this box. So what am I putting in that box? What does that line of code say for me to put in that box? 10. We're on line 5. Oh, you really scared me for a second. Right? Because it says P1, but don't actually go to P1, go to where P1 gets you to. Perfect. Now the next line of code is another weird one. It means P2 star, okay, well what's P2 star? Okay. There we go. But P2 star is this box. But what does, where am I, like what if I'm getting P1, I'm getting star P1. I guess I should have said star P2. So star P2 is here. Star P1, well here's P1, but here's what's actually there. So it's getting what's in that box and putting it in this box. Questions yet? Okay. Then what? Now it's saying P1 equals P2. It almost gets to the point now when not doing pointers. You have to stop and wait, wait, what? Because P1, okay, what's P1? Well, it's this. And it's saying, okay, what's currently in P1? The memory address, the pointer, the arrow. But what am I saying? I'm saying, no, get rid of this arrow, ditch this, and override it with what's in P2. What's in P2? A pointer to this, another arrow, an arrow that's going to be pointing to that box. So P1 is now going to be this. So the contents of P1. And why is it not the thing P1's pointing to? Well, because I didn't put the star in front of the P1 on that line. Then after that, I'm saying star P1. So here's P1. What's star P1? Where does that get me? Follow the arrow. And so now I have this box, and then what am I saying? Put in star P1. 20. Perfect. So now, as of right now, what's in first value? FV. Everybody else 10. What's in SV?
20.
Who said 10? It's 20. Does that help?
Yeah.
Now the trick, slow it down. If you're scratching your head, you're probably thinking too hard and trying to move too fast. Slow it down. Don't skip any steps. The only trick is, what are the rules? Other questions? So that was your question too, yeah?
No, mine was the one about the 2 stars.
Gotcha. Yeah, it throws me off too. I don't like it that way. Okay. Have a look at this code. Try to figure out what the answer is going to be. On one hand, this question isn't a trick question, but at the same time it kind of is. It depends if your head's still in the pointer place or not the pointer place or whatnot. Don't yell out the answer. Okay, I'm just gonna poll the class. Raise your hand if you think you have the answer in your head. Really high, I wanna see. Okay. Raise your hand if you think the answer is 3. Raise your hand if you think the answer is 0. Wait a minute. So what was the alternative? Like everyone in the class just raised their hand, but only like 2 people raised their hand for each option. That doesn't make sense. Let's try that again. Raise your hand if you think you have the answer in your head. That's something less people do, but really high, I want to see. Now, keep your hand, nope, keep them up. Keep your hand up if you think it's 3.
There are 3.
Well, yeah, okay, sorry, I don't really care about A and B. I'm really more interested in C.
Okay.
So that's why, okay, that checks out. Sorry, okay, let's try again. The big question is, what's C? Because it looks like we're like Z, right? The Z is like the trick, right? What's going on? Okay, before I'm going to poll the class again in 1 second, but before I do, I want to clarify something. In this situation, how many variables, who can answer this? How many integer variables currently exist in this program at a given time? There's 6 integer variables that exist. A, B, and C, X, Y, Z. They're separate. And then when I call the function, sum no pointers, when I give it A, B, and C, what's the value of A?
1.
Now, when we look at the function, X, the variable X, we copy over the contents of A and put it into the variable X. It's a whole new variable.
Is it not a parameter?
It is a parameter, but it's like a variable for the function. And the parameter are just like variables that are in the function definition.
Okay.
Yeah, but like you're right, it's just a more specific word for a variable in this scenario. Yeah. But they are variables and they're separate. And I actually copy over the contents of A to X, B to Y, and C to Z. And then what do I assign to Z in that function? X plus 1, which of course in this scenario would be 3. But here's the thing. That int Z, that variable, it's somewhere else. It's not the same variable as C. Did I ever change C? No. So then when I print out C down here, what's it going to be? 0. I'm going to draw that out, again, just so we're all following the rules. A lot of people will rush over the pointers and the variables and whatnot. Just give me 1 sec. I don't want to do that. I want to make sure we're on the same page. So we've got 3 variables, A, B, and C. What's in A? 1. What's in B? It's 2. And what's in C? It's 0. Great. I call that function. The computer now goes and creates 3 new variables for me. X, Y, and Z. And it says, okay, A is going to be the X, so I copy over the contents of A and put it into X. So I'm copying over what's in here. I'm copying over, I'm copying over. Then I execute the 1 line of code in that function, and I turn that into X plus Y. So Z becomes 3. The function returns, and this is our situation. Did I ever change C? Now, be honest. For those of you that came from Python last semester, who was thinking, no, I remember you talking about side effects. I remember side effects being a thing. And what's going on here? Why is there no side effect? Shouldn't that cause a side effect? Raise your hand if you remember me saying that. Good. I'm glad you remember, and that's important. There's no side effect here. The side effects in Python won't exist with primitive types. We wouldn't have, if we did this exact same code in Python, we did the exact same result. The side effects came up as soon as we started using the pointers in Python. Now you might think, we never had to deal with those ampersands and stars in Python, and you're right. But everything that's not like the primitive type, everything that's not an integer, a character, a boolean, a float, is going to be like a non-primitive type in Python. And everything there is a pointer. Every variable you have is a pointer no matter what you do. It's a pointer that automatically dereferences itself for you. C++, it's not doing any of that for you. C++, you have to be explicit. Is this a pointer? Is this not a pointer? It gives you more control. You as the programmer, it's giving you more control. You have more buttons and knobs at your control panel to take control of what your program's doing, which is cool. So Python was the one that was kind of like tricking you. It was cutting steps out for you. But it's important to remember that in Python, if this wasn't primitive types, it would have been pointers. So let me ask again. What's going to be printed out on the last line of code when I hit run? 0. Why? Because I never changed C. I copied over C and changed what was in the copy of it. That's it. So, you had a question.
Yeah, so like, Z was never a pointer, it was just sort of like a copy of C's value.
Exactly. It's a whole new integer variable. Yeah. Yes?
Could you print out, like, in Python, we could, like, print out the function? Can you do that?
No, C++, yeah, it'll be like, I don't know what this is.
Okay.
Python's the weird one though,
Okay.
not C++. Have a look at this one. Take your time. Let me ask you, how many integer variables exist? Don't say 6. Let's try again. How many integer variables are going to exist? 3. How many integer pointer variables are there going to be?
3.
Good. So now, what's actually happening? I am saying I've got A, B, C. Great. Then I call the function. And I'm saying create 3 new variables that are integer pointers. So these are my integer pointers. And what am I putting inside of them? The addresses of A, B, and C. How do I know it's the addresses? Well, I put the ampersands in front of the A, B, and C in the function call. So these are all going to be arrows. And then I'm saying, okay, go to what's at x, which is 1, add it to what's at y, which is 2, and put it into the box that like z points to. So what does this become? 3. So when I hit run, what's it going to print out of that last line? 3. So here's that side effect thing. Because I've got pointers. Do we remember what type of function this is if the function has a side effect? Who remembers what we call that? No? No, that's not the answer I'm looking for in this context. Who here remembers if a function doesn't have side effects? What do we call that? Pardon? A good one? We call those pure functions. Don't worry if you don't remember. This was like a footnote in 161. Now what's going to get printed out? Take your time. Look at the code. What does it actually say? And when I say take your time. Don't skip any steps. All right, somebody yell out the answer. 3. Was that what you're going to do? I appreciate you raising your hand. It's 3. Why? Well, because I calculate it, I return z, and put the result of the function call into the variable c on this line of code right here. That's why. See how its return type is int. That means this function is going to return an integer. Here's a weird one. This is really weird, and I want to be clear that I am trying to ruin everything. My mind will be blown if anyone can actually answer this question. I'm going to give you a minute. Try to think about what it's actually doing. And then I'll see if anyone is strange enough to know the answer at this stage. Is that a question, or do you think you have the answer? Okay, then we'll wait. I want to give everyone a chance. Okay, what are you thinking?
Would that just like break it? Is it characters?
Nope, it's going to work perfectly fine. What do you think? Nope, it doesn't print ABC. What do you say?
Considering that your integer doesn't maybe do like the ASCII value.
That's exactly what it's going to be. But you didn't blow my mind because I wanted to hear like 97, 98, 91. But that's okay. You don't remember them? You're telling me you don't remember or have the ASCII table memorized?
I haven't.
Sheesh, well, get it together. To be honest, I'm not even 100. I'm pretty sure it's 97. I always confuse the uppercase, lowercase. I could be wrong too. But you were right in the sense that what it's going to do is it's going to treat these as integers, even though they're characters. So what I'm doing is I'm taking the value of the character. It's not a string, it's the character C. Now, the funny thing in C++ and in C, and so a whole bunch of other old school programming languages, things that are primitive types are all going to be, they've got a type, but the type matters when you interpret the thing. What I mean is, if I have the character C, okay, which is represented, and what I'm about to draw is not the actual ASCII value of 90, or the binary, actually no, someone do me a big favor, go to Google and type in 97 in binary. You did? What do I write? Start on the left-hand side. Like the 00100.
Oh, in binary.
Oh, okay. You found the ASCII table? Was I right in 97?
Yeah.
Aha. So somebody tell me what is it? Like go to Google and type, what is it? Start on the left-hand side.
0,
Okay, you got it, yeah?
0, B, 11, B,
B, oh, that's hex. I want binary.
1, 1.
Okay, 0, 1, I guess, okay,
Yeah.
1, 1.
1, 1, 0, 0, 0, 0, 1.
Perfect. Okay, that's 97. Let's just go with it.
Change the third one with the first 0.
But is there still 3 zeros here?
There's 4.
Oh, there's 4. Good enough. Guy can have an infinite number of zeros here. The point I'm making is that's 97. That's the integer 97. That series of zeros and ones also means the character A, lowercase a. It means the same thing. What matters is how the computer is decoding this information. This is what we call an encoding. There is some information that has been encoded into this set of zeros and ones. I now need to decode it. But depending on my rules for decoding, I'll get a different thing. If I'm going to decode this as an integer, I'm going to decode it as 97. So this is equal to 97, which is also equal to the character A. It depends on how I decode it. So in this particular situation, I'm just being weird. And I'm saying, yeah, just, it looks like I've got A, B, and C, but really I've got 97, 98, 99. Oh, that's just me showing you something we already did. Ah. Does this make sense? Take a second, look at this code, take your time, think about this. Real quickly, what is A? A is a variable. It's just int. It's an integer. And if I say, what's the address of that? Can I ask what the address of an address is? Not unless that address is in a variable. Not unless it's in a memory location. That last line of code doesn't make sense. Because A is the number 5. Ampersand A means, oh, that's at memory location 4. Ampersand A would be like, well, I mean, that doesn't make sense. That's a silly question. Okay, by the way, we'll stop the lecture here.